Hi, today I will show you how you can implement flip-flop in HLS. This is the basic overview of flip-flop where one data input, one clock and one output. This is the simple characteristics table. When D is 1 at the positive edge of clock, Q is 1. If D is 0 at the positive edge, Q is 0. As you can see from timing diagram, where clock positive edge data is 0, so Q is 0, and when clock it at positive edge and data is 1, then output Q is 1. Here we will implement this project where there will be 3 D flip-flops, one our data input D, one clock input and one reset. When reset is high, all outputs will be 0. When reset is low, for the active low, and the clock pause edge, the D will transfer to Q. Let's do implement in HLS. Here I will create a new project. Simple D flip-flop projects, and then select a directory where I will just select D flip-flops, which is HLS, the project name. So that the top name is DFFs, and next. Then I will select the board. I have the Xilinx Zybo 7Z720 port. Now I will create a project source file for DFS or CPP, and .h file, tb.cpp file, tb.h file. In the header file, make practice, we will do this. Although we are not using this header file in our design. I simply written down the code for this cascaded flip-flop, where it is my boolean bool input and q1, q2, q3 as per our design, it's the output. The static variable for the intermediate outputs we assign initially zeros, and then this is important where based on the sequence we just assigned output to the next input. Initially D is assigned to this intermediate output, and then this here and the third flip-flop input, and then later on the third flip-flop output assigned to our Q3. And similarly we assign the intermediate outputs to our final outputs. Then after, Here we have to put the pragmas. So I will put just directives for the inputs, interface, and then select none. Similarly for other uh, inputs, just copy and paste for the Q1, Q2, Q3, Q1, Q2, Q3. Okay, and I will write test bench header file where I will include the main header file, this one, and then the main function, which is DFFs. We'll write our test bench. The test bench will call the test bench header file and then int main first initialize the status signal. We have to return something in the int function to print something on the output. I use string. It is not necessarily the same name, but keep for the simplicity the same name. Okay. Initially, d is 0, and then d plus we'll do some outputs here. We'll fill d with the output for the D0, D1, D1, and D0 and D1 just to test the case. After that, we'll do the simulation. Here you can see when B is 0, all Q1, Q2, Q3 are 0. When these 1, Q1 is 1, Q2 is 0, Q3 is 0. Then Q1, D1, D is again 1, Q1 is 1, then the previous one is passed to Q2. Okay, then D is 0, Q1 is 0, and the 1 1 is passed to Q2 and Q3. Then after D is again 1, Q is 1, then 0 passed here, and Q3 is 1. So as you clearly see that it's completely working as how D flip-flop should work. Now we will do the synthesis. As you can see in the synthesis report, there are 3 flip-flops used in this circuit. Now we will do the post simulation. Once it passes, we will open the waveform viewer. Here it's open, so we'll see. We'll put in a sequence. Again, you can see here that Q1 is initially 1 and then it passes in the next clock cycle to the Q2 and then Q3. Then there is 0 and 0 passing with two other flip-flops and then 1, 1 again passing to the other flip-flops. Okay, next we will export this as a IP for the Vivado. Once it exported, we will open the Vivado. We will create a project. Select the FPGA board. And then give the IP repository where you created your IP from HLS. Okay, then okay, and apply. After that, plus DFF. Here you can see we will only assign the outputs. We created these two outputs. The HLS by default append. And then after you can create wrapper for this. I will do the first simulation for this project. First, I will assign this reset to 0, clock from 0 to 1 in front 100 mega clock, and then I will assign this initially 0. Okay, and then after I will assign this 1. As you can see here, this is my Q1 and this is 1. Okay, and then this goes to 1 and then this goes to 1 at the next clock edges. I will do it again 0. Here you will see that this goes immediately 0 at the negative clock, and then this is happening in the negative because my clock start from the 0. Okay, so I can make this clock as 1 to 0 here, and then assign this initiative 1, and then force to 0. And then if I assign this as a 1, here you can see now at the posage of clock it is assigning the values to the Q1. Previously it was assigning at the neg edge because my clock was inverted. Here next I will assign this to 0. Then you can see the next value where it is 0, D0, then Q immediately 0, and Q1 at the next clock edge is equals to 0, and Q3 at next clock edge is equals to 0. Okay, thank you very much. Keep watching for